Okay, today we're going to take a look at the Maclaurin series, so let's go ahead and begin. Learning goal. Students will be able to know what the series is and how to use it. This is a special case of the Taylor series. We are finally on number 10. And remember, we're dealing with power series here, which are kind of neat. And basically with the power series, we learned earlier that we deal with obviously powers. Now for Maclaurin series, it's the same as the Taylor series. The only difference is this. The difference is I centered around 0. So basically I'm centered at 0, and that's a beautiful thing because there are different shortcuts and formulas that I can remember to regenerate the Maclaurin series. Now in this video, unfortunately, we're not going to talk about those formulas. We'll do that in a later video. We're just going to basically use Taylor's and plug in a 0, and then just to practice Taylor's. But Maclaurin is just centered at 0. Okay, very, very powerful tool. Alright, so let's see what it's all about here. We have the first question. It says, find the Maclaurin polynomial of p sub 5 for e to the x centered at 0. Not a problem. Now this means I don't stop at degree 5. This means I have 5 terms. So first things first, I want to regenerate the Taylor polynomial. So basically it's going to look like this. F to the 0 power of c over 0 factorial times x minus c to the 0 power plus the first derivative of c over 1 factorial times x minus c to the first plus f double prime of c over 2 factorial times x minus c to the second. And remember, I want 5 terms. So far I have 1, 2, 3. So I need 2 more. Plus f triple prime of c over 3 factorial times x minus c to the third. And then finally plus f to the 4th power of c over 4 factorial times x minus c to the 4th. Okay, we're in very good shape. Now our Maclaurin just means this. All these c's are basically 0. So that's the difference between the Taylor and Maclaurin. But first things first, I'm going to start off just like Taylor's. I'm going to take the first derivative in this column. I'm going to plug in because it's centered at 0. Alright, the beautiful part of f of x equals e to the x is basically the derivative is just e to the x. So f prime of x equals e to the x. F double prime of x is equal to e to the x. F to the 3rd power of x is equal to e to the x. And let's go one more. F to the 4th power is equal to e to the x. Okay, if we plug these in, you get f of 0 is equal to 1 because e to the 0 power is 1. F prime of 0 is equal to 1. F double prime of 0 is equal to 1. F triple prime of 0 is equal to 1. And you guessed it, f to the 4th 0 of 1 is equal to 1, excuse me. Okay, now we have enough information. Let's plug right in. So f of 0 is 1. This is really f of 0 because I don't take the derivative. So I get 1 over 1. And then x to the 0 power just makes 1. So plus, okay, let's plug in a 1 over 1 factorial times x minus 0 to the first. So that just makes times x. Plus 1 over 2 factorial. And this would be x to the second plus 1 over 3 factorial times x to the third. Remember that all my c's are 0. And then finally the last term plus 1 over 4 factorial times x to the 4th. So let me count the terms. 1, 2, 3, 4, 5. So p sub 5 is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. Done. You would stop right there. Please don't put a plus ... That means it goes on forever. We just want a partial sum here, so that would be your solution. Not too shabby, huh? Not too bad. Okay, so in an earlier video we looked at cosine centered at 0. Here we're going to look at sine centered at 0. And let's make sure we read the directions. It says they want the 4th degree So we actually wait till we have the fourth degree, and centered at 0 of sine x. Okay, same game. So I'm going to write out the Taylor polynomial, and then we'll just plug in. So f of 0 of c over 0 factorial times x minus c to the 0 power plus f prime of c over 1 factorial times x minus c to the first. Let me fix this x. Kind of got away from me. Plus f double prime of c over 2 factorial times x minus c to the second plus f triple prime of c over 3 factorial times x minus c to the third. Okay, I need to go one more because I want fourth degree. Plus, and then the fourth derivative of c over 4 factorial times x minus c to the fourth power. Okay, we're in good shape. Alright, f prime, and we have f centered at 0. So f of x equals sine x. That's our function. I'm going to scroll down a little baby bit so I have more room. Okay, I'm going to catch my breath. Let's do it. F prime of c, or x in this case, is equal to cosine x. The second derivative is equal to negative sine x. The third derivative is equal to negative cosine x. And the fourth derivative is equal to positive sine of x. Okay, let's plug them in. F of 0 is equal to 0. F prime of 0 is equal to 1. F double prime of 0 is equal to 0. F triple prime of 0 is equal to negative 1. And f to the fourth power of 0 is equal to 0. Okay, we're in excellent shape. Let me grab a different color for some contrast. Okay, let's start plugging in. The first one would just be 0 times 1. So I basically get this, which is just going to be 0. So we'll cancel that out in a second. Plus the next one would be 1 over 2 factorial times x to the first, because remember c's are 0 with the Maclaurin. Plus, okay, the next one would be 0 over, and let me make sure that I write this correctly. Here it looks like I wrote a 2. It really should be a 1. So let me erase this. Sometimes it's tough writing my own reading my own writing, and speaking, I guess, sometimes too. So 2 factorial, and then this would just be x to the second, plus the next one would be, okay, so I got this one, and then it would be negative 1 over 3 factorial times x to the third, and finally plus 0 over 4 factorial times x to the fourth. Okay, let's clean it up a little bit. That makes x, because this term right here is x, this goes to 0, and the next term would go to 0, because 0 times anything is 0, minus x to the third power over 3 factorial. So, and then this would go to 0. So unfortunately, even though I wanted to the fourth degree actually cancels out. So that's all I have for this one. Please know it's a partial sum, and I would need more. I would guess, for me guessing, that it would be positive because it looks like it's going to alternate, and I would guess I'd probably get x to the fifth, and then I would guess that it would be over x to the, let me erase that, 5 factorial, and my guess is right. And because I can see a pattern, I can actually come up with a formula, and that's what the next video is going to be about, the Maclaurin shortcut formulas. I call them the Big 7. Anyways, students will be able to know what the Maclaurin series is and how to use it. Remember, it's just a Taylor centered at 0. I'd see you on the next video.